Hello. In my last video I showed you how you could use the super cheap and very versatile ISD1820 board in combination with a multifunction timer to act as an automated audible RF beacon. Now if you haven't watched the video, please do so, but by all means, if you have come straight here, please keep watching. If you've followed my channel for some time, you might have seen it in the past. I've tried to use a repeater controller to control two radios to operate crossband as a repeater. I will link to the videos below if you haven't seen it. On paper this should be a simple task, but this just wasn't the case. Keeping separation between the two radios and RF pickup on the leads was just too much hassle to even bother with in the end, where the transmitted audio was so bad that it dawned on me that a much more simple approach like a Parrot repeater would be the way to go. Anyway, now before I start this and before people head to the comments section, in many countries using Parrot repeaters on FRS, Gmrs, PMR, CB, etc. is not legal, so please do check the laws in your country of origin before you use such a device. Licensed radio hams can operate and maintain radio repeaters, as we all well know, but this repeater isn't suitable for such operation, and the following design does not attempt to make it so. This is just for fun and a cheap solution that many of you can easily make and hopefully enjoy doing so. There have been many occasions when operating my PMR radios on holidays and trips that it would have been great if we could have, as a dispersed group, kept in contact using just the radios and not our phones. However, with the low power and limitations of UHF radios sometimes, the terrain and the conditions mean that this is not possible. A small cheap Parrot repeater is a great idea to overcome this obstacle, and something that I am surprised hasn't been built into a Chinese radio yet, but to my knowledge it hasn't. However, some radios like the UV8000D do offer cross-band repeat. One thing you will realise if you listen to PMR FRS radios is that the conversations tend to be very short, especially when kids are using the radios, so a Parrot repeater is an ideal solution with a short recording time to keep the overs nice and snappy. There is an off-the-shelf product available that does look quite good. It's £40 and would have to be imported. However, I have heard mixed reviews on it, and not wanting to waste more money on repeating hardware, I thought, well, the stuff I am using costs next to nothing, so let's have a go at making one. My design goal here is to make a customisable low-cost PMR FRS Parrot repeater for less than £10 UK. It has to be small and light, easy to operate and stable. I'll try and cram a battery in there as well. The unit will basically record any audio that it receives and instantly retransmit that audio up to a maximum of 10 seconds on the same frequency. The repeater can, if required, announce its presence every 15 minutes, detailing the repeater's CTCSS tone. A CTCSS tone would be needed to prevent too many rogue retransmissions or the transmission of interference. The receiving radio could also be set with DCS access as well to improve security. Now, I'm going to make two designs. The first will be an Arduino controlled device, and the second will be a 100% analog device using a very cheap off-the-shelf control board, so something anyone can make without having to worry about Arduino programming. Although, to be honest, it's much easier and more flexible to use a microcontroller like an Arduino. You can actually set the ISD boards to record at 20 seconds in length, but you will lose some audio quality. So the nice thing about using a microcontroller is that you can simply add in more ISD boards if you want greater length recordings, or a low battery warning say, or a tamper warning if it's remote, etc. Totally flexible, few lines of code and £1 per board. There are other versions of Arduino boards and other small microcontrollers which will record and play back the audio from the microcontroller using SD cards. However, I wanted to keep this super simple and cheap and without anything other than a few lines of basic coding. I've done some Arduino coding before, but I am really quite a newbie. However, I managed to write some code and a basic setup that works and controls the boards properly. This is going to be a two-part video. Part 1 covers the design and the concept with a basic test, and Part 2 will be the finished article with a quick run through of the code and a proper circuit diagram explaining all. Right, cut to me 3 days ago at the bench, ready to start work.
Right, and this looks like a bit of a mess, I know, but most of this is just a bit of R&D more than anything. One of the biggest problems with using these little boards, these ISD boards, is that they require a 3.3 volt input on the pins. You can use 5 volts, but I've heard that they don't like it after a while. So what I've had to do is put some resistors in for a potential divider out, because the Arduino output's at 5 volts. So I've actually got a little board that's going to do that conversion, which you plug into the Arduino, but just for now I've just rat's nested it with some resistors. The speaker, I saw someone else do this on an Arduino, on one of these. They just to get a bit more volume, I just tape the speaker to a toilet roll. It just gives it a little bit more volume for the test. But anyway, so at the moment I'm mimicking this, but I've got the code written in the Arduino. I've done that. I'm by no means a skilled programmer with Arduino. I spent hours and hours and hours reading through examples and prattling around, but managed to get something that works now, and it seems to work quite reliably. So I'm just going to give you a quick demo as it is now, and then I'm going to connect the radio up and then try it with the radio, and then on the second video I'm actually going to show you this inner box all working properly, and we should be able to make this up. I mean, the nano version of this, with the small version, is about £3. These boards are £1, so really for about £5 we should be able to knock up a good little PMR or whatever you want to use it for, Simplex Parrot repeater, and not have to pay silly money. And of course with this one, with it, the way I've done it is this board controls the actual play of the messages, and then this one will announce the repeater on the air every 15 minutes, triggered by the Arduino. The Arduino listens into the analog signal coming from the radio, and I have an adjustable threshold in the software which I can set to only trigger the PTT when it gets to a certain point, and it seems to work really well. I might have to do a little bit with something with screening these cables to prevent the RF getting in. It might have to go in a die-cast box, I don't know, but I think we should be alright at the power levels I'm looking at using with this anyway. So it's certainly a lot easier than trying to do this with analog electronics as such. It has proven to be a bit of a pain, but I am going to do a version with analog electronics, but there's more to it than you think. Right, so what we're going to do now is we're going to get this board off, or leave it, sorry, change this board to the repeater announcer, and I'll get the radios hooked up and we'll try it like that. Right, it's just a bit easier to get the camera off the tripod. This looks more complicated than it actually is. What we've basically got here is some status lights, green for play, red for record. Over here we've got the ISD1820, which we're using to record and play back the clip, and I've got a tiny little transistor amplifier there, which is used to amplify the signal to the Arduino, because it's a very high impedance input on the Arduino, and it just for some reason didn't seem to like the speaker audio, so built a little amp there to boost that up so I can detect that, and that's what does the switching for the actual repeater. So really, if I was going to take all the wires away and all the components, there wouldn't be much here. I've got some Variboard, just going to drop a few components on. I was going to do the potential divider, but I'm just driving these with 5-volt signals into that. It seems to be surviving, so I'm not too worried. They're £1 each, those are. So, and this is £6. So yeah, I've not blown any of these up, but I have blown one of these up. One of the ISD1820s, I did actually manage to blow one of those. Now if you're going to do this mod, you can see I've connected directly to the microphone input there, and that's not the way to do it, by the way. If you're going to do this mod, you actually have to, those two capacitors, C3 and C2, you have to take them off the board, because you need to connect directly into where the microphone goes. So all you do is just run a soldering iron on those, they just fall off, and then you actually, if I show you, I've actually connected it up. It's a bit dark down there, but you just connect directly to the board there. You definitely and then you just connect your audio straight to your audio out from your radio there. If you short the grounds on the 2 pins on the radio, then it will transmit, 'cause that's how it gets the transmit signal. So you have to keep that audio ground separate from the ground in the circuit. But I'll do a circuit diagram and all this, guys, if you're interested. But I suppose I better show you it working. Okay. What we do, we monitor on the analog pin on the Arduino. We're looking for an analog voltage over a specific value, which I've set in software, and it's adjustable. So when it detects the audio, it will transmit,
And the way I monitor that when I've been testing it is I set the serial monitor in the Arduino to print the values on the screen, the voltage values and the actual sensor values, so I can get some idea of what I'm doing. So if I just show you here, if I key up, you'll see the voltage value come up. Testing 1, 2, 3. There you go. You can see that's the value, 3.2 volts. Now that's being switched by that little signal transistor down there. That transistor there came from a box of bits I've had in the garage for nearly 30 years. It still works. So yeah, so that's good. Repurposing. So yeah, so what we have here, receive radio and transmit radio there, my handheld here, and I'll just do a test. I've got to tweak the audio a little bit. I think it's slightly over modulating a little bit, but this is all stuff I can do once it's all on variable board. So let's try this for a quick blast. Testing 1 2 3 1 2 3. Testing 1 2 3. The quick brown fox jumped over the lazy dog.
1 2 3 1 2 3. Testing 1 2 3. The quick brown fox jumped over the lazy dog.
There you go. So you can see it's working. I'm not getting any false triggers. Very, very simple program. I'll put the program details up for people that want to do this themselves. But yeah, I would recommend building this little amplifier. I think that transistor, if you were to buy it, is 10 pence and a couple of resistors, so it's nothing really. And you're going to need to put a little bit of a board of some kind in to make it tidy anyway. So a bit of variable, strip of variable, 50p, if that. So yeah, certainly for sort of £6 or £7 you can knock something up. I know you can buy commercially available products for, you know, £40, but this is totally adaptable. What I was going to do with this one is put another one of these boards in, and this blue light that's flashing here will trigger that. I think I mentioned it earlier on in the video. That will trigger that as a sort of every 15 minutes to announce its presence. So yeah, so I'm going to draw up a circuit diagram now while it's all here, so I know for my own purposes, and then we'll get it once the nanos come. We'll do the nano version of it and get it all in a nice little box. Right, I hope you've enjoyed that, and we can all get back to going on holidays and going out with the families and doing things that we enjoy doing, hopefully very, very soon. So if you've been enjoying the lockdown, I hope you're coming out of it now. We can all get out there and play, and if you do fancy making one of these, please stay tuned to the channel. If you haven't already liked, please do that now, and if you haven't already subscribed, do the same, and keep an eye on the channel, and we'll soon catch up on the next video where you'll see this all completed and you can have a go at making one yourself. So if you have been, thanks ever so much for watching. Catch you on the next one.